All right, continuing with Chapter 6, today is going to be day 1 of Section 6.2. 6.2 has got quite a bit of stuff in it, so it's going to take us a few days to get through this. The title of the section is Transforming and Combining Random Variables. Today we're just going to concentrate on the transforming. So we've got a strong connection back to something we already learned. In Chapter 2, we study the effects of transformations on the shape, center, and spread of a distribution of data. And this is what we discovered. Adding or subtracting, the rule was the same, a constant. Adding the same positive number A or subtracting it from each observation adds or subtracts from the measures of center and location, mean, median, quartiles, percentages. We usually concentrate on the mean and the median, were the two most commonly asked questions. But it does not change the measures of spread. Usually it's IQR or standard deviation, which range also fits that category. Okay, the multiplying or dividing, it's the same rule. Each observation by the same positive number B multiplies or divides the measures of center and location, mean, median, quartiles, percentiles, etc. by B. Multiplies or divides the measure of spread, range, IQR, standard deviation by B. It does not change the shape of the distribution. So, in summary, paraphrasing this a little bit, if you do a transformation that involves an addition, subtraction, or multiplication or division, the shape remains the same. The center gets affected by both the multiplication and the addition. The spread does not get affected by the addition, but does get affected by the multiplication. Right. How are the probability distributions of random variables affected by similar transformation to the values of the variables? So this is how it appears in Chapter 6. Okay, basically what's happening is in this description, we're adding or subtracting to each observation, multiplying or dividing each observation. With a random variable, it's each value of a random variable, each value of a random variable. So basically the effects are the same. Whether it's a probability distribution, as we saw in just a distribution of any kind, didn't have to be probability. Whatever happened here happens to the probability distributions in our Chapter 6. So let's run through and take a look at how that appears in our Chapter 6 context. Oh, we're not there yet. I'm sorry. One more background slide. Okay, sometimes that multiplying or dividing and then addition or subtraction can be described as a linear transformation. So your variable, which in this case is now a random variable, multiplied by something, added to something else. So after you do that linear transformation, the probability distribution of y has the same shape as the probability distribution of x. And normally, the measurements that we're concentrating on are the mean and standard deviation. Other measurements are valid, but most of the questions are going to revolve around that. So the mean is affected by both the multiplication and the addition, and the standard deviation is affected by just the multiplication, not the addition or subtraction. And they're emphasizing the absolute value. B could be negative. Typically, it's not going to happen in our context, but if it is, it would be times the absolute value. You can't have a negative standard deviation. Linear transformations have similar effects on other measures of center or location and spread. Again, we already talked about that in the previous slide. These are the ones that are most commonly addressed in AP questions. So whether we're dealing with data or random variables, the effect of the linear transformations are the same. And as far as the world that we're in, whether it's a discrete or a continuous random variable, the effects are the same. And we did some examples yesterday of each of those types. All right, this is going to be the scenario for most of the slides for today. El Dorado Community College, fine institute of higher learning. El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. The number of units X that a randomly selected El Dorado Community College full-time student is taking in the fall semester as the following distribution. So this is how many units, or credits is a more common term for college classes, and this is the probability of a student taking each one of those. So if you randomly selected one student from this college, there'd be a 25% chance that they're taking 12 credits or 12 units. All right, for the purposes of some of the investigations we're going to be doing, they're giving us, this is what the distribution looks like if we were to create a histogram. And you can create that on your graphing calculator. I'm not going through the keystrokes with that. Refer back to your notes on creating histograms. All right, the three measurements we're going to be concentrating on: mean, variance, and standard deviation. It's highly unlikely that you're ever going to do these calculations by hand. You should be aware, in terms of being able to read a general statistics formula, of how it would work, but you're going to do this on your calculator. You're going to take the number of units, put those in L1. You are going to take the probabilities, put those in L2. You're going to run a one variable statistics with L1, L2 as your X list frequency. The calculator is going to give you the mean, but it will give it to you in the X bar notation. You need to make sure you put it in mu notation. The calculator does not give you sample standard deviation. It only gives you population standard deviation. And then you're going to take that and square it in order to get the variance. In certain situations, you know the standard deviation first, in which case you square it to get the variance. In certain situations, you know the variance first, in which case you square root it in order to get the standard deviation. All right, so here's a transformation that could happen with this data. Okay, this is the same background information about El Dorado Community College. It's the same table. Now, the transformation. At EDCC, El Dorado Community College, the tuition for full-time students is $50 per unit. That is, if T is equal to the tuition charge for a randomly selected full-time student, T is equal to 50X. So $50 times each credit that you take. Each credit that you take is coming from up here. So here's the probability distribution for T and a histogram of the probability distribution. So 50 times 12 is 600. 50 times 13 is 650. 50 times 14 is 700, etc. So those are our new values there. The probabilities remain the same. Again, you would not be doing these calculations by hand. You would take these guys, put them in L1, take these guys, put them in L2, run your one variable statistics. That would give you your mu, that would give you your sigma, and then you square that in order to get your standard deviation. So, as a comparison here of our summary statistics and of our histograms. So this is mu sub x, which is the mean of the initial distribution, standard deviation of the initial distribution, variance of the initial distribution. And then we have our mu sub t's. This is for the tuition. Okay. A note I guess I should have emphasized in a previous slide, when you have multiple distributions happening in the same problem, you have to indicate what is what. So we can't have mu being this and mu being that without indicating, well, for which one. This is the mean of the credit distribution. This is the mean of the tuition distribution. So, things we should notice. The shapes of both distributions are the same. That shape is the same as this shape, whether it's the number of units you're taking or the tuition charge. The mean of the distribution T is 50 times bigger than the mean of X. Remember, means are affected by multiplications or divisions, additions or subtractions. The standard deviation of T is 50 times bigger than the standard deviation of X. Standard deviation is affected by multiplication and division, but not addition or subtraction. There was no addition or subtraction involved, so it wasn't relevant to this problem. Okay, we don't have a direct, nice, clean relationship here. Again, variances are not going to be what we're focusing on until I think it might be tomorrow's lesson with what the deal is with that. The rules we're concentrating right now are on if it's a transformation involves multiplication, that's going to affect the mean, it's going to affect the standard deviation, more information to come about the variance. All right, another transformation with our friends at El Dorado Community College. If T is the tuition charge for a randomly selected full-time student, T is equal to 50x. So X was that distribution, that was how many credits you're taking. So your tuition is going to be $50 times each credit you take. Here's the probability distribution for T and a histogram of the probability distribution. So we got that, and here's the histogram here. Okay, in addition to tuition charges, each full-time student at El Dorado Community College is assessed student fees of $100 per semester. If C equals the overall cost for a randomly selected full-time student, and C is equal to 100 plus T. So each one of these values here for the tuition charge, we need to add 100 to, and that gives us our new distribution, which is C, which is our total cost. So you would go on your calculator, you would run your one variable statistics on this data, or this distribution, and that's this right here. And again, you want to have some kind of indication in terms of labeling the distribution that these summary values go with. So we have these values from a previous slide. Those, the mean, the variance, the standard deviation of this, we've already calculated. That is now here. Okay, so what are the observations we need to make? The mean of the distribution C is $100 larger than the mean. So that plus 100 goes here. The standard deviation is the same, there to there. If the standard deviation is the same, then the variance has to be the same. The shapes of both distributions are the same. So emphasizing mean is affected by multiplication, division, addition, subtraction. Standard deviation is affected by multiplication, division, but not by addition or subtraction. To get from this distribution to this distribution was adding 100. There was no multiplication or division involved. All right, so all of those community college examples, we're dealing with a discrete probability distribution. The last example for today is going to be a continuous probability distribution. In a large introductory statistics class, the distribution of raw scores on test X follows a normal distribution with a mean of 17.8 and a standard deviation of 3.8. The professor decides to scale the scores by multiplying the raw scores by 4 and then adding 10. Define variable Y to be the scaled score of a randomly selected student from this class. Find the mean and standard deviation of Y. Okay, so X represents the raw score. Y is the scale score. So you're multiplying by 4, adding 10. That's what they told us the transformation was. That's the curve on this test. So the mean of Y is going to get affected by both of those things. So it's 10 plus 4 times the mean of X. 10 plus 4 times 17.2 is 78.8. All right, as far as showing work, the general rule of thumb for most things we do in this class, you're going to show the blank formula, show the numbers plugged in, show the final answer. For scores on tests, usually a label is not required. If it was something like pounds or feet or inches or something like that, you'd absolutely positively have to do this. You could put 78.8 points if you want it to be thorough, but usually it's not required. Now the standard deviation of Y is going to be 4 times the standard deviation of X. Standard deviation is not affected by that multiplication or division. So that's our blank formula. Plug in the numbers, show the final answer. So defining variable Y, that would be this right there. That the answer is the work. There's really not much to show there. And then finding the mean and standard deviation, that would be what would be required for full credit in terms of showing the work. Just having 78.8 without showing that, you're getting little or no credit. Just having 15.82 without showing that, you're getting little or no credit. All right, now a follow-up question. What is the probability that a randomly selected student has a scaled test score of at least 90? All right, now you want to be careful here because they could have asked us something about raw score. They could have asked us something about scaled score. So make sure you're using the right mean and standard deviation. The raw score, that was the mean and standard deviation. The scaled score, this is the mean and standard deviation. Okay, so using technology, normal CDF, lower, upper, mean, standard deviation, gives us that area, which means that's the probability. There's about a 23% chance that a randomly selected student has a test score of at least 90. Older rubrics, if you were to look them up, like Googling answers for old AP tests, many of them required that you drew a normal curve. The newer rubrics, unless it specifically says to draw the curve, you don't have to include the picture as long as everything else is in place. If you were lacking here, like you didn't have labels, but you had a here in your normal CDF, but you had well labeled and well drawn normal curve here, that can substitute for work by most rubrics. I would concentrate more on just making sure that you nail this really good and don't worry about showing the curve. Unless, of course, it specifically says to sketch the curve, then you want to make sure that you do that. All right, as I mentioned, 6.2 has quite a bit going on in terms of content. That's as far as we're taking it for today. And then next class, we're going to look at the next chunk of material from 6.2.